Hello, in this video I want to discuss VLBI simulations in VieVS. Although simulating session is very easy in VieVS, it's also very easy to make some mistakes, because you really need to understand what you're about to simulate and how you're going to use your simulation results. Let's have a look at the short summary. The tricky thing is that you need to understand the difference between the scheduled observations and the observations listed in the NGS and VGOS-DB files. In general, the number of observations listed in the NGS files is lower than the number of scheduled observations, because some stations might have some technical issues and drop out of the session, or maybe they drop out partially from the session, or maybe some of the models were not right and you will lose some observations for other reasons. Therefore, you really need to first think about what you're going to compare with your simulation results. First of all, the easiest solution is if you're only comparing some sessions that you all generated with VShape++ or any other kind of scheduling software. If this is the case and you're only investigating sessions that you really made by yourself, then you can simply use the NGS files generated by VShape++ in VieVS. Or it might be a lot easier to simulate your sessions directly in VShape++. If you're about to compare some sessions that you have generated with VShape++ with really observed sessions using the real NGS files, for example, then you need to be very careful, because you first have to convert the real observed schedule file to a new NGS file and use this new NGS file for the simulations. The reason is because in the real NGS files, all the observations are missing that dropped out due to some technical issues, while in the NGS files generated by VShape++, all observations are listed. Therefore, it would not be a fair comparison if you would use the real NGS file and compare it with the NGS files generated with VShape++. Another option you have is that you only want to simulate some real observed NGS files. If this is the case, then you can simply use the real NGS files directly in VieVS and do all your comparisons. This might be the case if you are testing new simulation approaches and want to investigate if your new simulation approach is reflecting reality better. The main point I want to raise here is that if you are about to simulate some artificial sessions together with some real sessions, you need to be careful and you need to make sure that the comparison is fair. And additionally, I want to highlight that if you are only about to simulate artificial sessions, then it might be easier to do the simulation directly in VShape++. However, in this tutorial, I want to show you how to do the simulation in VieVS. Let's have a look at VieVS. If you do some simulations, then you will often use NGS files instead of VGOS-DB files, because generating NGS files is a lot easier. You can load NGS files through File, Set Input File, Browse for Session. Now you can load any of the NGS files that you're about to simulate. For example, I will take some random session from the year 2020. For simulations, you don't need to care about opt files or anything else. Let's move to the Simulation tab here and have a look at the simulated parameters. You can see that by default we are simulating the slant wet delay, the clock drift, and also white noise. For the tropospheric parameters related to the slant wet delay, the most important parameter is the CN value. The higher the CN value, the more tropospheric turbulence you will have in your session. For the clock, you can define the Allen standard deviation, and additionally we will add some white noise, a couple of picoseconds of white noise. If you use the parameters as shown here, then you will use the same simulation parameters for all the stations. in case you want to have custom simulation parameters for individual stations, then you have to use one of the parameter files. Simply change the button here and then you can select one of the parameter files. The parameter files are stored in the VieVS VLBI data turbulence folder. You can have a look at some of the examples listed there or generate your own turbulence file. Let's have a look at one of these files. Here you can see that you can simply list all the stations and give them their own parameters. As I said earlier, one of the most important parameters might be the CN value. For this tutorial, I will use the same parameters for all stations, so I will not use any of the turbulence files. Another important thing is that you can define the number of simulations runs that you want to analyze. Typically, if you look at the repeatability values, you should aim for a high number of simulation runs. For example, you can make 1000 simulations. Next thing is you need to go to Run Options, and now you can again define a subdirectory name. For example, I will call it Sim for simulation. One important thing is that you have to check Run vSim here on the left. This will enable the simulation tool in VieVS. Similar to analyzing real observations, you can also change all the estimation parameters and also use parallel processing. But I've only selected one session, so I can click on Start. Now the processing is done and we can have a look at the output. As you can see, the whole process was very similar as for analyzing real sessions. First we did run vinit and we see that there were 11 stations in this session. Next we did run vmod to calculate the theoretical delay. Now the simulation starts and we did simulate 1000 runs. Next, the least squares adjustment did run for 1000 times, meaning you get 1000 estimate of all the parameters. You can see that every time you estimated 1208 parameters. After VLSM finished, you get a short summary of the result. Most importantly, down here you get a summary of the mean formal errors and the repeatability values of your estimated parameters. Since I've only selected one session, I will only get one line here. But you can see that in total we have simulated 5865 observations 1000 times. You can here see the mean formal errors for DUT1 and all the Earth orientation parameters, as well as the mean formal errors of the 3D coordinate vector. Down here you can see the repeatability of all these values. Up here you can see the unit of the values. If you want to reload this result, you can simply go to VieVS VLBI out, and here you should see a sim.mat file. It's called sim because I defined this name as the subdirectory name for my result. If I would load this mat file in MATLAB, I would have access to all these values again. For example, if I want to have a look at the repeatabilities, simply load this variable, and here is a list of all the repeatability values. This was everything I want to show you for the simulation part. The important takeaway messages are that you really need to understand what you're about to simulate to make some fair simulations, that it might be a good idea to use VShed++ for the simulations in case you make only a pure simulation study, and how you can access your simulation results and where it is stored.